Dear students, welcome to the chemistry class. This is our fourth chapter, chemical bonding and molecular structure. As we know that the matter is made up of one or the different types of elements and the attractive force which holds when various constituents are present like atoms, ions, etc. together in different chemical species. It is said to be a chemical bond. The attractive force is said to be a chemical bond. Why do the atoms combine? Why are only certain combinations possible? Why do some atoms combine while certain others do not? Why do molecules possess definite shape? These all questions we can't answer in a way. So there were different theories and concepts came, and out of that different concepts and theories, what we have to learn is the Causal-Lewis approach, the valence shell electron pair repulsion theory, that is said to be VSEPR, valence shell electron pair repulsion theory, valence bond theory or VBT or VB theory, and the last one is molecular orbital theory, MOT. So these four approaches are the theories we have to learn in this chapter. Now let's see the first approach, that is Causal-Lewis approach to the chemical bonding. In 1916, Causal and Lewis were the first to become independently successful in giving a satisfactory explanation about the formation of a bond, and that also in terms of electrons. They were the first to provide some logical explanation of valence, which was based on the inertness of the noble gas. Now let's see the approach. He pictured the atom in terms of a positively charged kernel. Kernel is what? The nucleus plus the inner electrons, or the nucleus and the inner electrons. And what about the outer electron or the valence shell electrons? It is accommodating maximum of 8 electrons, and this was his picture of an atom. He assumed that these 8 electrons occupy the corners of a cube which surround the kernel, and he posted later that the atoms achieve the stable octet. Octet means 8. 8. Stable configuration is 8. So when they are linked by chemical bonds, they will be having an octet. In the case of sodium and chlorine, we know that when these two combine, what happens? They form NaCl. And this can happen by the transfer of an electron from sodium to chlorine. Sodium has to lose one electron, which the chlorine has to accept. So in that case only this is possible. But in the other cases or other molecules like chlorine, Cl2 molecule, F2 molecule, H2 molecule, the bond is formed by sharing of a pair of electrons between the atoms. So both the cases it is happening. Now let's see what is this Lewis symbols. In the formation of a molecule, only the outer shell electron, that means the valence electrons, are taking part in the chemical combination or bond formation. So we need here only the valence electron for the bond formation or the molecule formation. And the inner shell of electrons, that is the inner electrons, are well protected and they are not taking part in the bond formation or the combination process. G. N. Lewis, an American chemist, introduced simple notations to represent the valence electrons in an atom, and these notations are said to be Lewis symbol. So we need an atom's outermost electron, and that electron, how we are representing, is named as the Lewis symbol. Let's see an example. Lithium. If we are having a element lithium, what is the atomic number? 3. And how we can arrange the electrons? We can write it as 2 in the first shell, and the second shell having 1 electron. So which we will take? We will take only the outermost electron, that is the 1 electron. So how we have to represent? We have to write the symbol of the element, and then the outermost 1 electron we have to represent with a dot. This is said to be the dot structure of lithium, or the Lewis symbol of lithium. Same way for beryllium, atomic number is 4. So we will write 2, 2. First shell 2 electrons, second shell 2 electrons. So outermost shell 2 electrons are there. So first we will write the Beryllium symbol Be, and then the two electrons in the outermost shell are represented with two dots. So this is said to be beryllium's dot structure or Lewis symbol. Same way for the boron, atomic number is 5. So 2, 3. 3 electrons in the outermost shell. So the boron is having 3 valence electrons. That is, the 3 electrons should be marked as 3 dots. Same way for the carbon, 4 valence electrons, so 4 dots. Nitrogen 5, 5 dots. Oxygen 6, 6 dots. 7 for fluorine. Neon 8. Like this we can represent the electrons or the valence electrons around the atom. And this is said to be the Lewis symbol. Now let's see the significance of these Lewis symbols. The number of dots around this symbol represents the number of valence electrons. When we are having a lithium with one dot, what we can understand that how many valence electrons are in there in that atom, only one. That we can understand. Same way, with that we can understand or we can calculate the group valence of the element. What is the valence of the group? Valence of group is for lithium 1. Valence is plus 1. That's why 1 is the group valence. Same way for 13th group it will be 3. Outermost shell 3 electron is there, so that 3 is the group valence plus 3. So we can find out the number of valence electron as well as the group valence of the element. And the group valence of the element is either equal to the number of dots in the Lewis symbol, or what, the 8 minus the number of dots. That way also we can get the group valence of the element. The next topic is octet rule. According to the electronic theory of chemical bonding, the atoms can combine in two different ways, either by the transfer of electrons or transfer of valence electron from one atom to another. That we can say in terms of gain of electron or loss of electron. And the other method is by sharing of valence electrons, and they do this thing to complete their octet in the valence shell, and this is said to be the octet rule. Next topic is covalent bond, and we have learned this covalent bond in our 10th standard. That is the bond formed by atoms when they share their valence electrons and attain the octet, and it is said to be covalent bond. That is, sharing of electrons between the atoms is said to be covalent bond. And there are three different types of covalent bonds. That is single bond, double bond, and triple bond. Only three types of bonds or covalent bonds are there. When two atoms share one electron pair, they are said to be joined by a single covalent bond. So the first type is single covalent bond. How it is? It is the sharing between only one pair of electron, and it is said to be single covalent bond. An example is like chlorine, two atoms we are having here. If we are having two chlorine atom, one atom will be having 7 outermost electrons. The second chlorine also will be having 7 outermost electrons. When these two combine, how they will share their electron? The chlorine, this first chlorine will take from the other chlorine one more electron and attain the octet, that is 8 electrons. The next one chlorine also, what they will do? 7 it is having, so one from the other chlorine it will take. That means there is a mutual sharing of one electron pair. You can see here in this closed structure only 2 electrons are there, though this makes a single bond. So you can write what? Cl, single bond, Cl. It's a covalent bond by mutual sharing of a pair of electrons. So this is the first type of covalent bond, single covalent bond. The next one is the double bond. How it is formed? When two, or if two atoms share two electron pairs, the covalent bond between them is said to be double bond. So two electron pairs should be shared between the atoms. An example is given with the carbon dioxide and ethane. Ethane. Now you can see the dot structure. If you are having carbon dioxide, first the central atom is carbon with 4 electrons, 1, 2, 3 and 4. The other oxygen on the both sides we are making two oxygen atoms. So first one oxygen with 6 electrons in the outermost shell. 1, 2, 3, 4, 5 and 6 here. Then the other one oxygen on the other side. 1, 2, 3, 4, 5, 6. All the 6 electrons are here. So now how it will share the electrons? This oxygen will take 1 and 2 electron from carbon, making it 8 electron. The other oxygen also will do what? It will share the 2 electron from the carbon and become 8 electron. Now what does this carbon do? Carbon is having only 4 electrons, so it will take from 2 from this oxygen and 2 from this oxygen. Now you can see the closed structure. This is the closed structure. Here how many electron pairs are shared? 1 pair, 2 pair. So how many bonds will be here? 2. Same way this side also 1 pair, 2 pair. So total 4 electrons are here in the closed structure. So making it a double bond. Carbon double bond O. Here also carbon double bond O is there. So this is the double bond formation. The second example is with the ethane. When ethane we are having, we know that 2 carbon atoms are there. So first we will write the 2 carbon atoms here. One hydrogen here on this carbon and the other hydrogen on this carbon itself. So 2 for this and the other side 2. So total 4 hydrogens are here. And each hydrogen is having 1 electron. All the 4 having 1 electron. Now you know that hydrogen, if it has to become stable, it needs 1 more electron. So from carbon it will take 1 electron and make it 2 duplet. Here also it will take 1, making it 2. It becomes stable. So like that all the 4 hydrogen takes the carbon's 1 electron to make the 2 electrons for him. Then what about the carbon? The first carbon, it will be having 1 and 2 here for it. This second, third and fourth is here. Now it will take from here 1 electron and from here, making it how many electrons? 6. Then 2 more electron it needs. From the other carbon it will take 2 more. So it becomes total 8 electrons. The other one, here how many? The carbon is having 1, 2, 3 and 4. It will share 1 and 2 from these 2 hydrogens, so making it 6. But 2 more it needs. That it will take from the other carbon atom. So total how many? 1, 2, 3, 4, 5, 6, 7, 8. So that means both the carbon atoms are having now 8 electrons each. So it is a stable compound. And how we can make the bonds between them? Carbon and hydrogen, only 2 electrons are there. That means they make a single bond. Like this, 4 hydrogens are making a single bond with the carbon. But what about the carbon-carbon bond? You can see here in this closed structure, 4 dots are there. That means 2 electron pairs are shared. That means it made a double bond here. So this is how we are making the double bond compounds. The third type of bond is a triple bond. How it is formed? When the atoms share 3 pairs of electrons. In the case of nitrogen molecule, like 2 nitrogen atoms, they combine, will get a triple bond. And also one more example is given, which we are learning, that is ethyne molecule. Ethyne molecule is C2H2. In between the 2 carbon atom, there is a triple bond. So we can explain the 3 different types of covalent bond: single bond, double bond and triple bond. The nitrogen molecule, we can see the example how. One atom of nitrogen is having 5 valence electrons: 1, 2, 3, 4 and 5. The other nitrogen is also having 5 electrons in the outermost shell. So 1, 2, 3, 4 and 5. Altogether 5 electrons each they are having. Now how we can form the bond? One nitrogen needs 3 more electrons. It will share with the other nitrogen the 3 electrons. So making it 8 electrons. The next nitrogen also needs 3 electrons. It will take from the other nitrogen the 3 electrons. 1, 2, 3. So total 4, 5, 6, 7 and 8 electrons it also attains. That means they are completing their octet. Now in the closed structure, how many electron pairs are there? 1, 2 and 3. That means we are having here triple bond. So this is the nitrogen molecule. The next example is for the ethyne molecule. So 2 carbon atom and 2 hydrogen atoms are there. So how is the arrangement? We are having 1 carbon with 4 electrons. So that is 1, 2, 3 and 1 of this The next carbon is having 4. 1, 2, 3 and the other one. What about the hydrogen? They are having only one electron. It's here mentioned so that we can draw the single bond. For that purpose only it is shown here. Otherwise you can make here. Now here also hydrogen is having one electron. So first of all what we are doing is not the center atom. We will do the terminal atoms complete or stable formation. Now how the hydrogen can be stable? With the one more electron. That means it has to share one electron from the carbon, and it will share the one electron from the carbon. If you are taking this hydrogen, then this carbon's one electron is shared. So here what happens in the closed structure, it will be having two electrons. That means a pair, making a single bond. What about this side? This side also the hydrogen will take from the carbon one electron, and the closed structure they will be having a pair of electrons. That means the carbon and hydrogen is having a single bond. Now you can see the carbon. Each carbon is having 4 electrons only. How many it need? It needs total 8 electrons. So 4 more they need. From where they will take? 1 from the hydrogen, this hydrogen, and 3 from the next carbon. So total 1, 2, 3, 4, 5, 6 and 7 and 8, making it 8 electrons. Same way this carbon also is having only 4 electrons. It will take 1 from hydrogen and 3 from the other carbon. So making 8 electrons to this carbon. Now you can see the carbon-carbon closed structure. How many electron pairs are there? 1, 2 and 3. That means the carbon-carbon is having a triple bond. So this way we can explain the 3 types of bonds. When a pair of electron is shared between the atoms, we say it as single bond. When 2 pairs of electrons are shared between the atom, we say it double bond. And when 3 pairs of electrons are shared, we say it triple bond. Now let's see some of the examples where we can understand the number of valence electrons, the Lewis structure, and each atom possesses how many electrons. The first example is hydrogen fluoride. The hydrogen fluoride's formula is HF. So in that how many atoms are there? 2 atoms are there, hydrogen and fluorine. Hydrogen is having a valence electron of 1. And what about fluorine? Fluorine is having 7 valence electron as its atomic number is 9. Now total how many valence electron HF possesses? 8. 1 plus 7, 8 electrons it possesses. Now the single bond if you are making, H and F single bond we are making here. We just want to understand whether this structure is correct or not. So we are making a bond between them. Now how many electrons are shared here? 1 pair, that is 1, and here 2. So out of the valence electron, 2 is used up for this covalent bond. So remaining 6 electrons are there. If we want to represent the Lewis structure, how we can represent? H, F and the 6 electrons on fluorine. You can see here the number of hydrogen atom. If this structure you are making, hydrogen, the bond is there. That's why 2 electrons are there. What about the fluorine? Fluorine is having 1, 2, 3, 4, 5, 6, 7 and 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8 electrons are there. So it's correct. The number on hydrogen is 2 and fluorine 8. So it's complete stable molecule. Now the next example you can see nitrogen molecule. And each nitrogen atom is having 5 electrons each. 5 plus 5, 10 electrons. If we are taking a single bond between the 2 nitrogen atoms, the 2 electrons are used up for the bond formation. The remaining 8 electrons are there. But it is not possible to represent in that way. That's why we are making here nitrogen triple bond. Then we can have the octet complete. Otherwise one nitrogen will be complete, the other one nitrogen will be having how many electrons? We don't have the full electrons, only few electrons will be there. So it's not correct. All the 8 electrons, remaining 8 electrons if you are making on 1 is not the correct structure. So what we can do is we can make a triple bond, and then we can see triple bond means here one nitrogen is having 1, 2, 3, 4, 5, 6 electrons plus these 2, 7, 8. What about this one? 1, 2, 3, 4, 5, 6, 7 and 8 electrons. So both the nitrogen is getting 8 electron each. But if you are taking only a single bond, what happens is one single bond is there, then remaining 8 electrons. How you will place? One of the nitrogen you will place 6 and the other one 2 lone pairs. Then when you check the octet is complete or not, it is not at all matching, because one nitrogen will be having 8 electrons and the other will be having only 4 electrons. So it's not the correct structure of Lewis. So this is the correct form. Now let's see the example of ammonia, NH3. In this, one nitrogen having 5 valence electron and 3 hydrogens, 3 into 1, 3. So total 8 electrons are there. Now you can see here, if you make the bonds between N and H, how many bonds you are making? 3 single bonds when you are making. How many valence electrons are there remaining? That is 2 only, because out of 8, only 6 electrons are used up for this bond formation. So 2 are remaining. That 2, when you place on the nitrogen, whether it is correct or not, you can check. Hydrogen with this sharing 2 electron, 2 electron, 2 electrons. So total hydrogen 2 electrons. What about nitrogen? 1, 2, 3, 4, 5, 6 and these two 7 and 8. So it's becoming octet. So this is the final structure for ammonia with the lone pair. Now see the next example, methane. 1 carbon, 4 valence electron and 4 hydrogens, 4. So 4 plus 4, 8 electrons are. When you make the single bonds between the carbon and hydrogen, this is the single bond structure. How many electrons are remaining? No electrons. Why? Because 4 bonds means 8 electrons are used up. So when you make the final structure also, you can get this only, because extra electron is not at all here. But you check the hydrogen's number and carbon's number. Hydrogen 1, 2, 1, 2, 1, 2, 1, 2. All the hydrogens are having 2 electrons. What about the carbon? It's having 1, 2, 3, 4, 5, 6, 7 and 8. So it's a complete structure of methane. Like this, carbon tetrafluoride, when you are taking 4 carbon, 1 carbon is having 4 valence electrons, plus fluorine 1 is having 7 electrons. So 4 are there. So 4 into 7 and total it becomes 32 electrons. When you make the single electrons or single bonds between them, carbon and fluorine, how many electrons are remaining? 8 are gone. So total 24 electrons are remaining. That 24 electrons, how you can represent? You can just place the carbon at the center, 4 bonds are there, remaining fluorine, how many electrons you have to place? You have to make 6 electrons or lone electrons on each fluorine, so that it becomes 24. Now you check the carbon's total number of electrons and fluorine, whether it is complete or not, or obtaining the octet or not, we have to check. So one fluorine if you are taking, you can see here 6 electrons are there plus the one single bond. So 7 and 8 is there. That means each fluorine is having 8 electrons. What about the carbon? 4 bonds are there. That means automatically it becomes 8 electrons. So it's again stable structure or the final structure, Lewis structure. The last one you can see ion, NO plus ion is there. So how many electrons will be there? 1 nitrogen, 5 valence. 1 oxygen, 6 electrons are there. But because of the plus charge, we have to understand from this 1 electron has gone. That means total 11 electrons were there. Out of that 1 electron, when it is going or losing, it becomes 10 electron. Now you make the nitrogen and oxygen in between a single bond. How many electrons will be remaining? 8. Now you can see here the structure, how you can represent. Nitrogen and oxygen when you place, if you make a triple bond, then this nitrogen will be having 1, 2, 3, 4, 5, 6, 7 and 8. Okay. What about this oxygen? It's having 1, 2, 3, 4, 5, 6, 7 and 8. And this way you can get nitrogen 8, oxygen 8 electrons. So the structure of NO plus is N triple bond O, the plus charge is there. Without that we can't write the dot like this. Otherwise one electron is lost. How we can understand? So this is how we can understand with the examples the remaining electrons, the Lewis structure, the number of electrons on each and every atom. Thank you. We'll continue in the next session.